Hello everyone, welcome to today's Knowledge webinar, Generative Design and Ansys Simulation in Creo. In this webinar, we'll be exploring some of the enhancements made in the latest release of Creo. This includes expanding the capabilities of generative design to take advantage of the cloud and introducing Creo Ansys Simulation, the second product created as a result of the Creo Ansys partnership. More about that later. And now let me tell you a little bit about Paul. Paul is a member of the Virtual Center of Excellence with PTC, a group trained in giving high-level overviews of all PTC's products. Paul specializes in the areas of Creo, aided by his background in mechanical engineering, engineering design, and 3D modeling. And now let me tell you a little bit about Knowledge. Knowledge is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, faster service, and above all, no headaches, especially these days. Check us out at knowledge.com. Our website is easy, intuitive, and you can always call us. Our phone number is basically on every page. And now enough about Knowledge. I will share Paul's screen in a matter of seconds. Here you go, Paul. Take it away.
All right, thank you, Barbara. I need to get my screen up here. And can you see that right now? Should say generative topology optimization.
Yep.
All right, perfect. So thank you for having me on today. And again, my name is Paul Dye. I am a member of the Virtual Center of Excellence with PTC. So our group is responsible for giving high-level overviews over all the different products, really of PTC in general, from Windchill to Euphoria, ThingWorks, and what I mainly focus on is really everything Creo. And so today that's what we're going to focus on is a couple newer and really kind of up and coming technologies within Creo. So that's what we see here is going to be around generative topology optimization and Creo Ansys Simulation. So throughout this, again, feel free to drop anything into the Q&A, ask any questions you might have, or ask me to elaborate on anything. I can definitely do that for you. And if there's anything that I can't answer, anything that I can't get too much into detail about, I can definitely reach out after the fact and get anything answered for anybody. All right, so for the two topics today, it's going to look a little bit like this. First, I'm going to go through some of the different challenges that we typically see out in the industry around the particular topic. We're going to go through the solution, some of the capabilities that it has, see a demonstration of it, and then briefly talk about some of the value that it provides. So the first thing that we're going to do that around is generative topology optimization. So looking into some of the challenges that we typically see, and one of the biggest things that we have to have a focus on really in general is driving innovation. That's whether you're making improvements to a previous design or creating new products that haven't been introduced to market yet. And that's true for many different industries. You know, you have to be able to create designs that not only satisfy the work that needs to be done, but it's also interesting. Either catch the eye of a consumer or just simply differentiating from whatever else is out there. And there's also the idea around closing the skill gap. In industries where you have workers retiring and new ones coming in, there has to be a way to create these type of designs. And even if your designers really don't have the same level of industry knowledge and expertise as those workers that are now retiring, or starting to get pretty close to it, you definitely need to be able to address that. And of course, you need to be able to do and accomplish more in less time than ever before. It really seems like every year that passes, we have to be more efficient in the way that we build our products, and we need the tools in order to get us there. So there's definitely a pretty wide variety of different considerations we have to be able to keep in mind as we start building into the future. And so we took all these different challenges into consideration, and we built out a tool with generative design here in Creo. So the main core functionality behind this is the generative topology optimization. And a real quick definition for it, it's our tool within Creo for autonomously creating optimal designs from a set of system design requirements, things like loads, constraints, preferred materials, even different manufacturing processes. And the system's going to generate the design that you or I probably would not have thought of. And it's something that we can either use as the base for a product that we can further refine upon, or even just as a means of concept generation for other different designs going forward. And throughout this, you can run as many different designs as you want. You don't want to just find a design that simply just works. You know, we want to be able to build those designs with all the different design goals and manufacturing constraints in mind. And then while the system's building out those designs, we're able to visualize real time what GTO, or generative topology optimization, is creating. And that's even true whenever we make modifications to any of the input geometry or criteria that's defining our study. And then right from within GTO, we have the ability to interrogate and analyze things like stress values that we're seeing in the model, get an idea of how the model is going to deform. And after we've had the chance to analyze the results that we're getting, very quickly go back, modify the study, change the geometry, change load cases, and just see what that does to the models that you're getting back. Really try out any if thing that you're thinking of, right? What if I change this? What if I change that? Well, don't think about it. Just try it out and see what type of geometry you're getting back. And one of the reasons we're able to do that is because it's all integrated right within Creo Parametric. So we integrated this frustum technology right within the modeling environment. It's not even a separate window or different software we have to switch over into. Just stay right in the same interface. And all we do is go through, define the geometry, say which things we can change, even which things we can't change, and any constraints that we want to put in, and just let the system go. And once the system generates that design, you've had the chance to review it, and you can go ahead and output the results to use elsewhere in Creo. You could take it for further refinement, optimization, simulation, anything you want to do from there. One of the ways we do that is by converting to solid BREP geometry, and we have the ability to compare the reconstructed geometry with the design that we got from generative topology optimization and see what changes were made to go from that tessellated geometry to now fully manufacturable parts. So it's not just nice to look at, it's actually something that we can send out to get casted, to get put on a 3D printer, whatever you want to do to actually create these designs. You can also do things like deviation analysis to get visual numerical feedback on how well we're matching up with the initial tessellated generated design. And around that, we can see things like minimums, maximums, deviations, all based on a surface normal. It's all helping us to get to the best design possible. And quick, I also did want to mention on one of the pieces of this that's coming up here with one of the newer releases of Creo, and that's going to be around the full generative design extension. So it's something that is really going to take what we have here with GTO and bring it to the next level. So this is now looking to really take advantage of what we have with being able to compute things in the cloud. So what we'll see here is throughout the demonstration, I'll show the initial geometry creation and how we set up different things for manufacturing and materials. And normally with GTO, we simply just run that on our computers locally. But now with the introduction of GDX or the generative design extension, we're now going to be able to send these things up into the cloud. And that's something that once we have it up there, we're able to go through, filter through designs, see all the different things that it's giving us as available options, things like material choices or strength values or all the different things that we're getting back through results. We're able to filter through all these designs, and we could say run 20, 30 different things through generative, have them all run simultaneously while we're free on our computers to do whatever else we want. Let the cloud do these things that we can just simply go through, filter through results, compare what we get, evaluate the things that we're seeing, and then finally choose the design that we'd like to move forward with. And then once you do that, you can then take it all the way back to Creo, right on your platform, where you're free to go forward, go through optimization, do further really design work on it, because this can be really the base for what you're doing going forward. So it's taking advantage of what we're going to see today and really utilizing the cloud to do some of those important things. So with that, I'd like to take us through a brief demonstration of what we have here with generative topology optimization so we can get a little bit better of an understanding of some of the things I talked about. And again, if you have any questions, feel free to drop those in and we can address them here at the end of the webinar today. All right, so here we go. We have our model that we're going to be working with today. And we can get started. So we're going to go through and do a little bit around our topology optimization tool. And the area that I want to look at initially is up here around the steering mechanism. So let's go ahead and zoom in there. So specifically, I want to look at this lower yoke. And right now, it's actually a design that works perfectly well, but it's something that maybe is 2 years old, it's last year's model, whatever it is. And I want to see if I can cut down some of the material around it or just improve the design. Well, I might know some of the different design goals I'm after, but I'm not exactly sure how I'm going to get there. Well, that's a perfect candidate for taking into generative topology optimization. We can go ahead here and open up our part to get going. Right, so here we can see I have that same yoke part. but a little bit more simplified version of it. So this is going to be the base I'm going to begin to work off of. And you can see here that I start with just an overall envelope. This is where we're really going to be an envelope or just a container for everything we're going to be designing around today. And then on top of that, we also have another body that is our preserved geometry. So this is all the geometry that once generative design has gone through and created something, it is for sure going to include all of this geometry. So that's something that we want to lay out before hopping into the study. And with that, we can simply go up into our applications and click on Generative Design to get going. So again, not even another window or different software we have to hop into, same exact interface to go through and start to work with our generative design study. Now, first thing we'll do is click our starting geometry, which again is going to be that overall envelope, and do the same thing with our preserved geometry. Just make sure that's going to be included in the final design. Right, and then from here, we can go through and lay out some physics. So starting first, we can define some constraints to say where the part's going to be held. I have a pin going through the middle. And then we can apply our loads, in this case, along the outer surfaces or these holes on either side. And with any of those, we can go through, change the values, change the units, really whatever normal operating temperatures or values or loads or whatever it might be. All right, from there, we can go through and work with the design a little bit more to lay out some design criteria. So in this case here, what's our goal going to be? Well, I know I'm trying to take weight out, maybe fill just about 2/3 of that volume. And from here, we can also lay out some design constraints. So in this case, we have things like planar symmetry or material spreading, just to change the look and the feel for how it's going to actually create that geometry and make sure that it's going to be symmetrical about a plane that you select. But also on top of that, we have manufacturing constraints. These are things like build direction if you're doing additive manufacturing, or maybe parting line if you're doing a cast. Different things that you can take into account depending on which way you're really looking to manufacture these parts. In this case here, I just want to lay out a planar constraint, put that across the middle so we make sure that it's symmetric about that. And lastly, I can put a material that I want to use. Probably going to get different results depending on what we choose here. In this case here, we're working with an aluminum alloy, and that should cover just about everything we need in our design criteria. Final thing I can look at here before getting into the study is some of our settings. We have options for fidelity to optimize on either speed or detail, a minimum element size, or even a maximum amount of iterations that we want to run. But with that all laid out, everything's ready to go, and all I need to do from here is click Optimize. And now the system's taking all this physics and design criteria we laid out and automatically building out the design. And we can visualize all the steps real time, the iterations it's taking, and from there, we're done. And it's really quick. We can go through and analyze the results that we get. So right on the model, we can take a look at things like von Mises stresses, see exactly where we're getting minimums, maximums. Go ahead and move up to the top of the model. We can see where our hotspots are going to be up around that top part. Even go through and check out the displacement, see if the part's deforming the way that it should be based on the loads and the constraints we set up. And with that, take it one step further. And we can animate on the deformation, go through and change the speed of that animation, change the scale. It's really a very visual way of doing this type of work. And if we're not happy with the results we got back, just as easily go back, make changes to any of the definition of the study. But if I am happy with what I got, I can then choose from here to generate the design. So right now I'm going to take this tessellated geometry that I have now and reconstruct it to a boundary representation, aka BREP, that I can take over into our full Creo parametric tool. So rather than just being stuck with a tessellated file, which we often are, we can now in Creo get real manufacturable surfaces that we can work off of. This will be our additive model. And now Creo is going to go through, reconstruct all that geometry that we went through and built out in the study. And just like that, it's all part of the Creo model. I can add it right back in with my part. Just simply use some Boolean operations in this case to merge our geometry back in with the preserved geometry that we started with. And just like that, we have a solid Creo model. It's ready to go. And it looks good. But oftentimes at this point, what happens? Someone on my team says, hey, Paul, we got to make some changes, right? Maybe the outer diameter moves. It goes from 58 to 48, whatever it might be. We have to make changes. Now, does that mean now that we have to go back and change all our study, do everything from scratch? Well, no. You simply use a lot of those things we had from before and then just say what we want to look at. In this case, let's put our limit volume around 70. Again, put that planar symmetry, but also in this case now, one thing that I know is I don't have a 3D printer that I have to create these things. I have maybe a mill, or I'm planning on using a linear extrusion process to create our part. Well, we can go ahead and lay that out here. So you can really take into account all these different manufacturing processes. We don't have to have 3D printers and everything around additive manufacturing to create these designs, which oftentimes it seems like you do with generative processes. You can really take advantage of any manufacturing technique and really get some awesome designs using generative. Again, here we can go through and change anything around the study settings, change the maximum iterations. And with that, we have our study ready to go. And in this case here, I've already gone through and run this study, so we can simply go through and open up the results that we got after we went through and converted to the BREF geometry. So whereas before the design was really only possible using additive manufacturing techniques, this is a part that now could be manufactured in other ways, such as milling, linear extrude, anything like that. And simply just add it back in like we did from before, and we're good to go. So that's just a quick look through a couple different ways that we can go through and use generative design. We could take it further and take it into things like our simulation tools within Creo, any steps further that you want to go from there, and even just general design, take it further, work with it from there. So just a couple examples working through that. And with that, obviously, lots of different value and a lot of different benefits that we can get from working with generative. And the first thing that we're reducing is time to market. Able to go through and not only try out different designs faster, but do that optimization right along with it, where normally it might be kind of two separate parts of the process, but something that we can now combine into really one congruent, really simultaneous process while you're doing that. And at the same time, probably most obviously, have the ability to deliver innovative products. It's something that's going to be very easily differentiated on the market. So you're not only getting the market faster, but you're getting there with a product that works and looks amazing. And throughout that process, also reducing product costs. We're able to reduce things like material costs throughout that, even part number. If you take a design that would typically take 20 to 30 different parts, you can cut it down to 5 or 6 with this generative style design. That's a lot of processes cut out. That's a lot of manufacturing time, a lot of manufacturing costs, and really a lot of money saved throughout that. So obviously a lot of different benefits that we get from that, and really some great design that we can do using generative. So any questions around that, feel free to drop in, and hopefully there's some really good information in there you can take forward and really hopefully integrate into your Creo processes. So from here, I think we're going to take our next segment now and go into what we have with the Creo Ansys Simulation tool. So this is the second tool that we built out with as part of our partnership with Ansys. Kind of getting ahead of myself a little bit there, but we can take a step back and really go through the similar process we did with the generative design. So first I want to go through some of the different challenges that we typically see with people that want to run analysis. So really to start, we need to understand how our products just perform in the field. And we need to understand how products react to different situations, how they perform under normal operating conditions. And we also need to be able to incorporate that into the way that we do design. And one thing that's great for doing that is analysis. It's a great tool for getting that type of feedback. But typically designers, engineers just feel they don't really have the necessary expertise to run simulations, especially as you're beginning to get a little bit more into the refining stage and get further along in the design. And what normally happens and what we see is engineers either have to consult an expert or send it out to a third party to do that analysis. And most times when you do that, it takes multiple iterations back and forth between the designer, the analyst to reach a product that's end up verified. Just generally a very disruptive process, really slows down the design cycle. A lot of times leads people to either, not liking it or just avoiding it entirely. So it's definitely a big issue with the way that we've traditionally done this type of analysis. So what we've done here is take that and really a lot of other challenges into consideration, and we partnered up with Ansys to provide a solution right here within Creo. So the first tool that we built out with as part of that partnership was Creo Simulation Live. So this is something that integrates their Discovery Live engine into the Creo parametric tool, where it's used as more of a design tool for building out better designs from the earlier stages of the design. But what we're doing forward from here and really taking that partnership a step further is by introducing Creo Ansys Simulation, which is taking high fidelity Ansys powered solvers and put them into the hands of the designer or engineer. So first and foremost, it's a very comprehensive tool for doing linear static analysis. That works for structural, thermal, and modal use cases. And so throughout that process, you have a simulation tree that you're using to set up and manage multiple different studies. You can even copy and paste loads between different setups, copy and paste constraints. It's just built out in a way that makes it very fast to try out lots of different use cases and anything that you want to look at there. And setting up the studies is very straightforward. We're going to see a little bit of this. All the loads and constraints, lights, set up very realistic situations in a way that works really well for the designer or engineer that's working with the model. So if you have something that was also set up in Creo Simulation Live, you can use that as the base for a study. You can just apply that directly in Creo Ansys Simulation. So working between those two tools is really a breeze as well. And another great capability that we have throughout this, and we're going to see as well, is automatic meshing and contact handling. So there's no need absolutely to have any prior meshing expertise in order to be able to build out very accurate meshes very quickly. And you do have more advanced options for controlling the mesh or refining it in certain areas that you want to focus on. And also handling contacts is done in the same way. You're able to have the system automatically detect contacts for you, but you still have the ability to manually define contacts as well. And again, it's Ansys. The same exact technology that's used in their platform is being used here to give you high fidelity results. And those results that we're getting are very highly visual, very interactive. You have a very customizable results legend to display both basic and more advanced results. So you also have the ability to query anywhere on the model, interrogate certain spots that might be of interest. You can place simulation probes, again, things that we're going to see. But probably the greatest thing about this tool, and similar to what we have with the generative design, is full integration into Creo, right? That's something that is really beneficial all the way throughout the process. Everything you're doing is the same, consistent user interface. So if you've used Creo at any point in the past, you're already halfway there to knowing the tool. And another thing with that is no data translations. For the model, the geometry that you built out, it's the same model that's used in Creo Ansys Simulation. And even if there's changes to the geometry, full associativity down the line to the analysis information. And also, if you want to take that analysis even further, you do have the option to export the simulation study to be used in the full Ansys workbench, probably more likely being done by the dedicated analysts or the experts, but you do have that option as well. All right, so what I'd like to do now is go through a demonstration of this, and I think a really good starting point here would be to do it on a structural use case. So that's what we're going to go ahead and do here. Let's switch back over into Creo now, and we can go ahead and get going. So I'm going to be using the same data set that we have from Royal Enfield. So for this one off that bike, we're actually going to use the rear arm assembly. And again, staying right here within Creo, and we're going to work with a standard structural analysis. We can see over on the right, we have some base forces, possibly wherever it's connected back in with the main assembly. We also have a displacement constraint. And what we can do from here now is go ahead and add in our own constraint. We can add in a cylindrical constraint over here on the left-hand side of the model. This is very straightforward to do. We can simply go here like we see, select on any of the surfaces that we want to constrain, and we're good to go. And with that, we have most of the base setup complete, but with this being an assembly model, one thing that we need to do is define the connections between the various parts. We can define these contacts manually, or we can have Creo Ansys Simulation automatically detect those contacts for us. And once those contacts have been detected, we can then move into our meshing tool. So this is where we're going to go through and have our control over the mesh if we'd like. So if we want to have a higher resolution mesh, it's just as easy as dragging that over to the right. If you want to keep it a little bit more coarse, a little bit lower of a resolution, you can move it over to the left, but it's very quick to go through and change that up. We also have things that we can change around the global mesh size like we see here. So we can get that mesh size right where we want it, change anything about the growth rate, anything around that. And local mesh refinement is also an option we could choose, but for now we're just going to go ahead and generate the mesh. So this mesh generation process is run by the solver, so the time that it can take can depend a little bit on the size of the model, but while it's doing that, we can monitor the progress and the status of the mesh generation down here in the process manager. And once the mesh is generated and all the setup's complete, we can go ahead and run the analysis. Let's go ahead and stop back here and simply click run. We can again use the process manager to monitor the status of the simulation studies that we're running. And while it's running, it displays the number of processes that we have running, as well as the ones that were completed for the current session. Again, the solver and the meshing technology that's used in Creo Ansys Simulation is the exact same technology that powers the Ansys Workbench platform. And that's part of the reason why it's so easy to move between the different applications. You know, bringing your studies over from Creo Simulation Live, refine those results here in Creo Ansys Simulation, and if you wanted to export to the full Ansys tool to further expand upon the capabilities. Again, probably more specific to the full-scale analyst. All right, so we can see it's pretty quick to go through and run through. And now we can move over and check out our results. So with the results, there's really two main categories for simulation results. We have basic and advanced. So we can see here in the basic, we get von Mises stress, displacement magnitude, displacement in the different directions. You see we immediately have access to those. We can check them out in the legend. So we can see right around 85 megapascals at a max right now. We can also see that Creo Ansys Simulation highlights the max area right on the model itself. We can take a closer look at that. See it's getting right down in the bend of that bracket where we're seeing the max. Also taking a quick look over here on the other side of the model, that seems to be a little bit less than we got in the first area. So now if we want to get more specific information on that area, we could do a simulation query that pulls up the values at specific points in the model. We're able to dynamically change that around at different points. And also around this, we also have the ability to place a probe on the model. So these probes exist as part of the analysis model. We can have those update for different variables or different result types as the studies run. Or even as you make changes to the study itself, the values that you can get there will update. And you can do that over in the simulation tree here. So you can have that update and see exactly what we're getting there. All right, so that's just a quick look through one of our examples around the von Mises stress. Another area of interest that I might have is around the displacement in the model based on the loads that I had laid out. So that's something we can move into now and take a little bit of a look at the displacement that we're getting. So we can have this applied and have a contour plot showing up on some of those results. And because I defined that after the analysis was run, I can simply just update the results here for the new things that I want to look at. So it'll be fairly quick to go through and run through those updates. And once it's updated, we can go ahead and take a look at what we got. So just a quick glance at that, we're seeing a max displacement around 0.02 millimeters. You can even get a better understanding of it by animating on that deformation if we'd like to, see exactly how the model reacts. And we could also turn off or on the mesh visualization if we'd like to. But for now, what I want to do is move into refining my analysis. So based on some of the initial results I got, I know the areas where I'm seeing the most amount of stress. So what Creo Ansys Simulation allows us to do is add a little bit of selective detail into the mesh to get even more accurate results in those specific areas that we define. So on my model here, we saw the most stress was occurring at those outer surfaces of the bracket. Let's go ahead and create a finer mesh in those particular areas. And what it's doing here is overriding the global size settings that we initially set up for the model and allows us to get even more detail into the areas that are important to us. And we can go ahead and generate that mesh again, see what that looks like. And again, check back at the process manager, see how we're doing with that run. And it's already gone through and completed the most of the mesh. We're good to go. And now it's regenerated, we can then display that up here on the model itself. Let's see what that looks like here. And see definitely a bit finer geometry in those areas of the bracket now. All right, so I've gone ahead, refined the mesh based on some of my initial findings. And what I want to do now is rerun through the study that we got. Again, we can turn right back on that probe that we set earlier and go back up into the top and run the study. And again, while it's running, we can go through and check the progress. We can see that it shows here the completion percentage for the mesh, shows the solve for the analysis definition itself, and then also for the result that we want to display. I'm going to let that run through here now with our updated results. And once it finishes up, which doesn't take very long, we can go through and look at our updated results. All right, first thing, let's look at our von Mises stress. Go ahead and our basic results here. All right, so we can see it's actually located at the same spot, but now it's actually increased a little bit, up to around 91 megapascals of von Mises stress. Even though it's increased, that's actually meaning that we got to a higher level of accuracy by refining that mesh, really getting our results where they need to be. We can go ahead over to the right-hand side as well and check out our probe that we had set. And we can see that the value here is probably increased as well, from about 77 to 87 megapascals. And really, that's the general workflow for an end-to-end structural simulation. It's very easy to go through, get that set up, and get some very high fidelity runs through very quickly. And again, with Creo Ansys Simulation, lots of benefit, lots of added value throughout that process. So what it's giving us first and foremost is a deeper integration of simulation throughout the entire design process. It's no longer just a disjointed system where you have design and analysis in two completely separate worlds. What we've done really is integrate the two together so you can start enjoying the benefits right from the start. And this means shorter development cycles, less time sending a model back and forth to go through many different iterations and prototypes that probably could have been avoided. And that's not only saving you time and money, but also getting your products out to market much faster. At the same time, mitigating the risk of product failure down the road. And all these things are important, right? But probably the most important thing is we're creating better products. Products that begin with innovation in the early stage of the design, things like generative that allow us to really break some of the biases we come in with. And as we go through, we can craft, optimize during the detailed design, and then at the end, validate using the high fidelity analysis that we have here with Creo Ansys Simulation. And with that, that's really all I wanted to go through and discuss around those two topics today. So with that, I can take any questions that we might have, or if not, then we can go ahead and wrap up for the day. But for now, I'll pass it back over to you now, Barbara.
Thank you so much, Paul. We have no question, but we're willing to wait a couple of minutes. In the meantime, I'm going to take the screen and I want to show everybody where they can find PTC products on our website. Just you can search for Creo and all the different iteration of the product. We also have Creo Live Simulation. It's very easy and intuitive to find. And as I said, Novage is changing the way designers purchase 3D software because we have all the choices and you have the freedom to pick and choose, and we have the advice that goes with it. So give us a call, don't hesitate, we're always here for you. I still don't see any question, Paul, so I'm left with thanking you for today's presentation. That was awesome as usual. Let me know, if you want to watch this again, you can go on YouTube and Vimeo, just search for Novage. Again, we're still waiting for questions. We're still here for you. But since I don't see any, I will wrap it up and say goodbye to everybody and thank Paul again. Have a great rest of the day. Bye-bye.
Have a good one, everyone.
Bye.